Let's work on example 6.5. We are asked to find energy stored in the inductors and capacitors. For capacitors, the energy can be calculated using this formula. WC of T equals 1 over 2 C VC of T square, and then WL inductor gonna be 1 over 2 L IL of T square. So in order to find this energy, we need to find the voltage across capacitor and the current go through inductors. For this exercise, we're going to find voltage across the capacitors and the current go through inductors. And then once you have those, you can just plug it in, and that's something you can do yourself. Under the DC condition, inductors is going to be the short circuit. As we said in class, if you pull from the left side, right side, then it's gonna be straight. That's the short circuit. And for capacitors, if you pull from both ends, it's gonna be open circuit. And then the circuit looks like this. We have IL of 1 and IL of 2, VC of 1, VC of 2. We can use different method, but for this video, I'm gonna use all those three. So first, we're gonna use mesh analysis. Second, we're gonna use nodal analysis. And then third, we're going to use superposition. We have a mesh current I sub 1 and mesh current I sub 2, and there is independent current source between two mesh current. So this is the case where we need to use super mesh. So super mesh, we don't want to name the super mesh. It's there, but we don't see it. We just pretend to, ignore in the middle independent current source. Starting from left-hand side, independent voltage source, that 9 volts. So following the direction, -9 plus 6I1 plus 3I2 plus 6I2 equals to 0. So we're gonna simplify this a little bit, and that is 6 times I sub 1 plus 9 I sub 2 equals to 9. So now we have one equation. The second equation we can get is we have to use 3 amp. So we're gonna do KCL at node A. Entering I sub 1 plus 3 equals leaving I sub 2. So if you move this I sub 2 the other side and 3 the other side, we have I sub 1 minus I sub 2 equals to 3. I sub 1 minus I sub 2 equals to 3. Now, based on this, using these two equations, use your calculator, we can get I sub 1, and that is the same as IL1 equals negative 1.2 amp, and I sub 2, which is IL2, and that is 1.8 amp. So now let's find VC1 and VC2. So look at the VC1. So we can do KVL at 1, -9 plus 6 times, that's a IL1, right? -1.2, and then plus VC1 equals to 0. So make sure you're following the direction and entering the negative terminal. IL1 is -1.2, so the actual current is going in that direction. That means we have a plus minus, that is 7.2. So if we do KVL, -9, 6 times -1.2, which is -7.2, plus VC1, from here, VC1 equals 10.2 volts. Okay, now for VC2, this node and this node, VC2 and the resistor 6 ohm, they are the parallel because the top node and bottom node, they are sharing. Therefore, whatever the voltage across to 6 ohm resistor, it's gonna be VC2. So we can say VC2 equals 6 times IL2. That is 6 times 1.8, and that is 10.8 volts. Okay, so now we have a VC1, VC2, IL1, IL2. You can use the equation for the energy. You should be able to find that. Now, let's try to find the VC1, VC2, IL1, IL2 using nodal analysis. Let's do the nodal analysis. I'm going to call this as a node A, and we can call here as a node B, and at node A, we need to assign the direction of the current. So this is already we did, that's good. And then 3 ohm resistor here and going down. Okay, so this is already there, and this guy is gonna be 9 volts. So node A. Okay. Now what we need to do for the nodal analysis, we need to basically do the KCL. So entering 9 minus VA over 6 plus 3, those are the two entering current to node A, and the leaving equals VA minus VB over 3. So we have one equation. At node B, we have entering VA minus VB over 3 equals leaving VB minus 0 over 6. For the nodal analysis, we need to assign the direction of the current, and you need to follow that direction. So the first equation, the arrow going from 9 to A, so we need to say 9 minus VA, and then leaving, we have an arrow from A to B, therefore we need to say VA minus VB. Okay, make sure you follow that. And the ground is always going to be 0. So that's why we have a second equation in second term, VB minus 0 over 6. Now, if you multiply 6 and here's 6, we have 9 minus VA plus 18 minus 2VA plus 2VB equals to 0. So I multiplied 6 for the right hand side and move them to the left. So we have that negative 3VA plus 2VB equals negative 27. And from the second equation, if you multiply 6 everywhere, 2VA minus 2VB, move it over minus VB equals to 0. 2VA minus 3VB equals to 0. 2 equation, 2 unknown. Then use your calculator. VA equals 81 over 5, which is 16.2. VB equals 54 over 5, which is 10.8. Look at the VA. Here is a VA, and this is all same node. This is all same node. VA equals to VC1. VB equals to VC2. And the same reason, they are parallel. Now, what about IL1 and IL2? IL1, when we set up the first equation, 9 minus VA over 6, that is actually IL1. The current goes through that line. So that is 9 minus, what was VA? 10.2 over 6. So IL1 is going to be negative 1.2 M. And then IL2, we have a VA minus VB over 3. That is IL2, and VA 10.2 minus 10.8 over 3, and that is 1.8. Now we're gonna find IL1, IL2 and VC1, VC2 using superposition, and you can do the second part same way. Those part are easier. So for this, we're gonna just work on IL1 and VC1. In the superposition, we need to turn off all the independent current and voltage sources but one. In this case, we have a one independent voltage source, one independent current source, so we need to have two different circuits. So if we turn it off, the voltage source is gonna be short circuit, and if you turn off current source, we're gonna have open circuit. The rest of the circuit for both cases look like this. I named those two currents with one more number. So the left hand side, we have a 1 and 1, so IL11, IL21, and the right hand side, we have a IL12 and IL22. So in the superposition, after we calculate IL11 and then find the IL12, that is actual IL1. And similar way, VC1 equals VC11 plus VC12. IL12. Now let's find the IL1 and VC1. If we redraw the circuit, clean up all these open components, then we have this 6 and 9, and this is IL11. When we use current division, and actual current is gonna go this and this. IL11 equals, we need to put negative because it's the opposite of actual current. So the opposite resistor 9 over sum of those two parallel resistors 9 plus 6 and times total current going in, that is 9 over 15 times 3, that is negative 9 over 5. So for IL12, by looking at the circuit, it is one giant one loop, and IL12 is same as IL22, and there are 3 resistors and 1 voltage source, so that equals V over total R, 6 plus 3, 9, 9 plus 6, 15, and that is 0.6. Therefore IL1 equals IL11, which is negative 9 over 5, that is negative 1.8, and then IL12, which is 0.6, so we have IL1 as negative 1.2 M. Now let's take a look at VC1. So now we need to find VC11, and VC11 is parallel to 6 ohm resistor, and actual current is gonna go in this direction. So this has to be plus, this is minus, and VC11 is 6 times the current, that is 1.8, and that is 10.8. And VC12 on the right side of the circuit, we know IL12 that is going in that direction with a 0.6. Therefore VC12, we can do KVL right here, negative 9 plus 6 times 0.6 plus VC12. Then VC12 equals 5.4 volt. So when you plug it in here, VC11 10.8 plus VC12 5.4, so the total is gonna be 16.2